All right, class. Welcome back from spring break. I hope you guys enjoyed a little bit of time to yourselves. Hopefully, if you were bored, you had a chance to look at some of those optional math contests that I put on Google Classroom. Feel free to share your scores on those if you want to show off how you did. But for today, we're going to be right back working on circles again. Um, we'll be doing lesson 10.1.4 from our book. But before we get into that too far, I just wanted to make sure that we haven't forgotten the other things that we've seen in chapter 10 regarding circles. So if we just take a look real quick at circle C here, I want to go over some of the new vocab and what that really means in terms of our circle. So a few things we had seen, we'd been introduced to arcs and the difference in their measures compared to their lengths. So let me get an arc created here. So if we're looking at our arc, let's call it XY, it's opening from our central angle at XCY, and the measure of this arc will have the same measure as that central angle opening up to it. So let's call that measure, I don't know, 70 degrees. That means that arc XY has a measure of 70 degrees. Just remember that arc XY is a minor arc we're talking about. If we wanted to talk about the major arc, which would be the remaining portion of the circle, we would pick a third point, like point Z, and we would name that major arc XZY, so that we knew we were talking about the portion of the circle not taken up by that 70-degree arc. So that was one fact we came up with. Another thing we ran into was, well, instead of having our angle opening up from the center, it's possible to have an inscribed angle, which means that its vertex touches the outside of the circle, and it's opening to that same arc XY. The difference here will be in the measure. So if you look at angle XCY compared to my new inscribed angle, let's call that XDY, you can see that my new angle looks narrower than my original, and it turns out it was actually only half the size. So it'll be 35 degrees instead of 70 degrees there. And those were important relationships because then we could find arc measures, we could go backwards, we could find angle measures. If I clear out some of these things I've created here, let's see how that works. We're getting there. All the way back to just our plain old circles where we're headed. So if we go back to our original circle, we'll still keep that center point C so we can talk about circle C. The other thing that we were introduced to were chords. And I actually created chords when I created that inscribed angle. But a chord was described as anything that connected through the circle to 2 points on the circle. And so if I draw a chord such as chord EF, it hits the circle at point E and point F, and it travels inside the circle, so that's a chord. We can have it intersect with another chord and see if there's any kind of relationship there. So if I draw a second chord, and let's call this one GH, we could see there was in fact a relationship here. We have vertical angles that we know are the same. And then if we were to create full triangles by connecting those points, you would see that at angle E, we're opening up to arc GF. And angle H is also opening up to arc GF. Since they open to the same arc and they're both inscribed angles, they must have the same measure. So that was a fact that let us use similar triangles. And that way, if we knew, like, that relationship, we could use ratios to come up with a value like x there, since they were similar triangles. So that was all important stuff that we learned regarding circles. If we jump to today's lesson, in it, you'll be learning about something called tangent lines and secant lines. And those are similar to chords in that they have a special relationship with how they intersect and interact with our circle. I'll let you guys read about them specifically in the lesson before we talk about those. But we'll really focus on the tangent line today and one special property. So at this point, go ahead, start the lesson, and then once you're done, come back here for a quick recap. Remember, from classroom, you were only assigned 38 through 41, so problem 42 is an optional extension problem if you wish to do that. All right, guys, good luck. And welcome back. So hopefully you're back here now because you've completed that lesson. Let's just run through some of the main ideas quickly here. So in 38, they really got us thinking about what was going on. We saw that a tangent line was a line that touches your circle at exactly 1 point. So it doesn't really appear to travel inside the circle, it just touches 1 point on the circumference of that circle. Whereas a secant line is actually something that intersects your circle at 2 points. And that's similar to what we've seen with chords. However, a secant line might keep going, where our chords were stopping right at the circumference of that circle. Hopefully nobody was able to draw a straight line that intersected that circle 3 times, because I think that would have really been challenging. That's actually not possible. So if we look at tangent, they asked you to use tracing paper and do folding, and I know I'm not providing you tracing paper right now, but hopefully you were able to sketch that on your own paper and do a fold to see that at point P, that tangent line is actually perpendicular to the radius drawn from point C to point P. And so that is the property we're looking to use with tangent lines, is that they'll always create a right angle when they are connected with the radius of that circle. 1040 kind of goes through a nice proof about why that can't be true for secant lines. And so if we look at that really quickly, if we go back to our circle, so in our circle, if we look at a secant line, and we assume that when we draw the radius from point C out to where the secant line connects, if we assume that's perpendicular, right away we run into a problem, because, well, I can't even fit my right angles in there correctly, but if I have 2 right angles in that triangle right there, I've already gotten myself to 180 degrees, and that's not going to be possible then to still have a measure for angle C. So we're not perpendicular at secant lines, but at tangent lines that property does hold true for us. Equipped with that knowledge, you were set to tackle 1041, where you were practicing using your different properties of circles, your new relationship with tangent, parallel lines were in there. So lots of good practice using all of these properties. You have the answer key where you can check your answers, but be sure to ask me any questions if you get stumped and you don't come up with an answer that matches the key. Remember, for today, we're not going to be doing the review and preview, so you don't have to submit anything. It's just up to you to make sure you understand the content of this lesson, and then ask me questions during office hours if you still have them. Remember, office hours are every day from 9 to 11, and you can just really quickly send me a private comment on Google Classroom, and I'll get back to it in real time. All right, guys, good work today, and have a great rest of your day.